All right, everybody have your homework out? All right. Nate, you had a question number. Which number? Let's take a look at number 6. Number 6. So, first and foremost, remember these things can flip around on your head. So you're thinking of this shape. It's a pyramid because the sides are triangles. Okay? It's sitting like this right here. In order to calculate the volume of a rectangular pyramid, we use the formula. Well, from the book, it says V is equal to capital B times H. Not very helpful. Okay? B stands for base area. H stands for height. Well, I can see the height is 6. The base area, or the shape of the base on this thing is it looks like a parallelogram. Remember, they draw that to represent your rectangle. So in this case, it's a rectangle. So the capital letter B is length times width times height. Except we have one small change, right? This is for a prism. To make it into a pyramid, we have to take the whole thing and divide it by 3. Okay? Remember the little video where it showed that 3 of those make a cube. Okay. So we take length times width times height, we divide it by 3. Hey, 6 is nice because there's only 3 numbers here. It becomes more challenging when they show you all the measurements. Then you got to be careful which numbers you pick. Because they could tell us that this edge right here is, I don't know, 10 centimeters. It might be, might not, I don't know what the distance is, but it might be 10 centimeters. It's certainly bigger than 9. Or sorry, it's certainly bigger than 6. Okay. So multiply the 3 numbers. 9 times 6 times 5. And then we divide the whole thing by 3. 9 times 6 is 54. 54 times 5, 2270. Is that right? And 270 divided by 3 is 90. So we get 90 cubic centimeters.
It's actually meters.
Oh, I'm sorry, meters. I'm blind. No, that's just me being old because I wrote centimeters right here instead of meters.
Wait, did you just call yourself old?
I am old. All right.
How old are you?
In March 13th, I'll be 56. All right. All right. Anyone else? All right. Let's grade this. Here we go. Let's grade this.
Is this equal 90?
Yes, 90 meters cubed. All right. I think I got to sneeze. Nope. All right. I need you guys to be quiet so you can grade your papers. Here we go. Number 1, 252 cubic kilometers. Number 2, 12 cubic miles. Number 3, now I did say round in there is 10th, 2010.6 cubic feet. Number 4, 552.9 cubic kilometers. Number 5, 126 cubic inches. We just did number 6, 90 cubic meters. Number 7, 72 cubic miles. Number 8, 80 cubic meters. Number 9, 130.7 cubic yards. Remember when they do cylinders, they are using pi key, not 3.14. Number 10 is 12 cubic yards. Number 11 is 8 cubic miles. Number 12 is 96 cubic inches. Number 13, 200 cubic feet. And the last one, number 14, 10 cubic inches. Now, you should have a good feeling right now. Are you getting these right or are you getting these wrong? When you count up how many you got wrong and you have 0 wrong, you're all over it. If you're like, wow, I got them all wrong, we got big problems, right? You got 1 or 2 wrong. Those are the ones you got to figure out what your mistake was. Don't be satisfied with just, well, that one's wrong. Figure out what's your mistake. Jackie? For which number? Let's take a look at number 9. Number 9. First off, what's the shape? It's frozen. What's the shape?
Triangle.
It is not. It's a rectangular pyramid. The formula for a rectangular pyramid is length times width times height divided by 3. All right, well, that was easy. All right, are we good? What do you got, Jackson?
What is the shape for number 2?
Number 2? Number 2 is a,
Triangular.
look at the sides.
Triangle.
Look at the sides. What are the sides? So it can't be a pyramid, it's got to be a prism. The sides are rectangles. You're like, wait a minute, I see triangles. Yeah, but how many triangles do you see? 2, right? Everything else is a rectangle. In order for it to be a pyramid, you got to have at least 3 triangles. You can have more. I mean, if it's a pentagonal pyramid, then you're going to have 5 triangles. What? Pi r squared h. What's the radius? Pi r squared h. Did you square the radius? So grab your calculator, type that in. You have everything correct. You just did something wrong. Yeah.
So for number 4, I got 0.64.
Is it a cylinder?
0.9.
Remember what I said. The computer program uses the pi key, not 3.14. So if you use the pi key, your number is going to be slightly larger than if it's for someone using 3.14.
So 4 is not wrong.
As long as you got something that was pretty darn close, and by close I mean within a tenth. That's not the radius, that's the diameter. That's not the radius, that's the diameter. You did 8 squared. That's not the radius. 4 squared is not 8. 4 squared is 4 times 4, which is 16. All right. One person collect, one person pass out, and that person is always Grayson. Grayson, you're like dead or something. I've never seen you so lacking energy before.
Grayson is always there.
Yeah.
Grayson just super tight. He's always super. That's Grayson.
Grayson, are you really that dead?
Grayson is always there.
It is, the entire chapter is worksheets. All right. Everybody hush, and we shall get started with today's fun-filled adventure into another shape.
Hey, Donovan.
All right. We just collected. Here's your calendar. We are going to take a pause. Today is not the last volume. Our book 9-8 is Spheres. But we do have a pause between, I'm talking over some people. Would you like to teach the class? Then stop, please. We're going to take a pause between volume and surface area. 9.7, A and B are surface area. 9.8 is a sphere. I wish we would do spheres right now. I'm not sure why it gets a whole section all to itself for both surface area and volume, but it does. So we'll take a pause tomorrow. We'll do a review of all the volume formulas. So it'll just be a worksheet tomorrow that reviews all the shapes. Make sure we're good to go on that. Then we'll knock out 9.7 next week. We'll do 2 review days because this is a whole bunch of formulas. And then we'll take our chapter test. Homework tonight, 9.6b. Hey, you got to pay attention. I literally just said every section is a worksheet. Pay attention. Didn't say for you guys to start talking either. Absolutely not. I've yet to see you make an A.
I haven't.
You're not getting A's yet.
Yeah, I have.
You made a B,
No,
and then you made a D, and then you made an F. and you made a, I don't know if you made a C this, but you certainly, your grade is not an A yet. And no, that's not a deal I make with anybody, just because you get an A, you get to pick your own seat. When you get to high school, I have open seating, but you're not in high school yet.
One more year.
And it's open seating until you prove that you're a knucklehead, and then you get a permanent seat. So some of you next year will probably have permanent seats. Thank you.
Aw, he'll be a permanent.
All right, here we go. Remember, this entire section that we're on right now, or the middle part of the chapter, all deals with volume. The first part dealt with area. The third part deals with surface area. But for right now, we're still in volume. We got one more shape to do. All right, we did pyramids yesterday. Remember to draw a pyramid, right? If it's a rectangular pyramid, you don't draw a rectangle, you draw a parallelogram. And it's only because for visual to make it look pretty. It's not that it really is a parallel, although all rectangles are parallelogram, but it's not truly a parallelogram in the sense of the classical shape of parallelogram. But we draw it that way so the pyramid looks pretty. So you draw a parallelogram, you put a dot above the middle, and you connect the dot to the vertices of the parallelogram. You make a pyramid. Okay. Pyramids come in all shapes and sizes. It doesn't have to be a rectangle. It could be a hexagon, could be a triangle as well too. The process of drawing is still the same though. For the sides that you would not be able to see, you make them dotted or dashed. There's your pyramid. Okay. Parts of a pyramid, though, the tippy top is called the vertex. That's where the triangles all meet at the top, called the vertex. The bottom of them are called the bases, not because it literally is the bottom, because remember, I can take a pyramid and I can turn it sideways, and the base is on the side. Okay. However, the base is how we name our pyramids. And then lastly, or second to last, the sides of a pyramid are called lateral. Lateral just means side. Face, right? The faces of all pyramids are triangles. The faces of all prisms are rectangles. Lastly, the perpendicular distance between the base and the vertex is called the height. We looked at the little video here that showed us that if we start with a square, this is for square, a square pyramid, right? All the pyramids have squares on the bottom. I'll show you here in a second. Yep. There's 3 squares, right? So it's a 3 square prism of pyramids. When you put them together, it makes a cube. Therefore, the formula for volume would be one of these. Since the volume formula for a cube is capital BH, or length times width, right? And we're doing one of them, it would be 1/3 length times width times height. Okay? That is the usable formula, 1/3 length times width times height. But that is only for a rectangular pyramid. There are other ones. And the other one that we did was triangular one. But you saw last night, it's not a hard calculation. If it is rectangle, it's length times width times height divided by 3. Do the math, you get your answer. For the triangular one, this is the weird one. People will look at this and they will see not pyramid, they will see prism, right? You're going to have 2 little tiny squares. One square will come from the middle, that's the height, and the other square will be somewhere else on the triangle, and that will determine or delineate the height of the triangle. You get this big honking formula. By the way, this is what's in the book right now. If you look at your book for triangular pyramid, this is what it says. However, let's make our life a little bit easier. 1/3 times 1/2 is 1/6. And that's my formula. The subnotation right here, the T and the P stand for triangle, triangle, pyramid. So it's 1/6 times the base of the triangle times the height of the triangle times the height of the, not prism, but pyramid. Once again, notice on a triangular pyramid, you get 2 little squares. One of them is the base and the height of the triangle. One of them is the height of the pyramid. The height of the pyramid always comes from the center, at least for this year. Okay, with geometry, it changes. But for this year, it's from the center. Okay, from the center to the top, that's marked, and you're going to follow your arrows here. 10. It looks like the base and the height are 6 and 8 of the triangle. 6 times 8 times 10 divided by 6. We get to our answer. Okay, there's your quick review. Next shape is this one. Imagine if instead of a rectangle or parallelogram, instead you had a circle. Now that doesn't look like a circle, that looks like an ellipse, because once again, just like for the pyramid, We don't draw the actual shape of the bottom of it, right? Either the triangle or the rectangle. We draw a parallelogram or a squished triangle for a triangular pyramid. For this particular shape, we don't draw a circle, we draw a squished circle. We still put a dot above the middle, and then we connect the dot to the, well, there's no sides, there's only one side. We connect it to the far edges. And if you do that, you make this shape, which is called a cone. Now, if you really drew a cone, you would not see the back part. So in reality, we make the back part so it looks like that. That's your cone. And Hannah, if your cone looks like this, are you happy or unhappy? If your cone looks like this, are you happy or unhappy? I'm not happy. You hold your cone like that, that's what happens. Right? Don't hold your cone like that. All right. So write this down, please. Box 1B. 1B. Draw me a cone. 1B. Draw me a cone. Put a circle. Put a dot above the middle. Connect the dot to the outside edges of your squished circle. Make the backside dashed and you have a cone. Let's label the parts. Take a wild guess of what we're going to call the tippy top. Take a guess what we're going to call the bottom. Where's your sheet of paper? Make sure you're writing this down. Now, we called for pyramids and also prisms. We called the sides the lateral faces. The issue is here is the face here is a polygon, a triangle, or a rectangle if it's a prism. On a cone, what's this shape? Where do you see a triangle?
Nowhere.
There's no triangle here at all. What's the shape?
Triangle.
Where's a triangle?
Right here.
That's not a triangle.
Yes.
A triangle is made up of 3 segments. Where are the segments? There's no segment there. It's curved. There's no segments. There's no circle here except for there. That's the base. Okay. What's the shape? And here, it's a trick question. It does have a shape, but it's not a polygon. Therefore, we can't call it a lateral face. For cones, we call it a lateral surface. And the issue, like I said, if you look at the pyramid, it literally is a triangle, the sides. The side of this is not a shape. Well, it is, sort of. We'll talk about it in surface area. But it's not a recognizable shape. It's not a triangle or a square, or pentagon, anything like that. All right. Those are the, oh, one last part. What did I leave off?
Height.
The distance between the base and the vertex is called the height. And yes, it will have a little tiny square as well. There are your 4 parts of a cone.
It's pi base height.
Well, if it's pi base height, then it's not a cone, it's a cylinder. So the question is there a relationship between these 2 things?
Yes.
They both have the same bases, same size. What's the relationship? What does it look like?
One's not a triangle.
How many of these would fit in this?
One.
Hey, I can literally put this inside of
Yeah,
there and there's
one.
empty space.
Yeah, but no one like to be
How many of these would fit inside of here? Wouldn't most people? You're saying that if I put this inside this, I make this?
No.
So how many of these would it take to make this?
One base. Oh, okay.
All right, he's got it now. Now, most people would intuitively say when they literally look at these 2 shapes, they would say what? They would say 2. It turns out that it ain't 2.
Is it 3?
It's 4. 1.5. It's 1.5.
This is literally using the same things I have, except his are smaller. You're dealing with a cone that is the same height as the cylinder. They're literally the same height. and the circles are equal. There's
I thought you
one.
meant like that
Hold
instead
on,
of
watch the
two.
video. There's one.
No. What do you think?
There's two.
Not really.
It ain't two.
Two and a quarter. Quarters.
There's a full one.
2 and a quarter.
Is it really 3?
It's 3.
Why?
Why?
It's not intuitive, is it?
No, that doesn't make any sense.
But like,
What?
it counts if you put one upside down and two of them the other way.
Right. I mean, you can kind of now wrap your head around it's 3, but I'm saying intuitively, when you physically look at how big this is or how big it appears, it certainly doesn't seem like I could fill 3 of these inside of this one thing. And well, you can.
So.
All right. So guess what the formula is for a cone?
It's the same thing as triangle.
It's the same thing as this, and then we
One divided by 3.
divide it by 3. So what's the formula of this thing?
1/2
Pi r squared h, and then we have to divide by 3. That's the formula. All right. So that is the formula. We take the formula for volume of a cylinder, which, well, technically it's BH. Once again, the most useless formula ever. Or you could argue it's the most useful because it works for almost everything. It's just not very descriptive. Instead, we're going to say pi r squared h. That's a cylinder. And since 3 of these make one cylinder, then one cone would be a third of that. So it's just, well, it's 1/3 BH. Once again, I don't like that. So we go with that instead. Not calculator friendly?
Calculator friendly.
Calculator friendly. Write this down, box 2.
See,
Box 1A, you were supposed to draw a cone. That was just, hey, how to draw a cone. 1B was the parts, and box 2 is the formula.
wait, we only have 5 boxes?
It's just one shape today. It's not that complicated.
Wait, so you're telling me we might be able to finish our worksheet today?
I don't know. We'll see.
If we stop screwing
All right.
around?
I've lost count on how many formulas we have, but it's a bunch. What will get you through the test is you show up with a resource card. My 7th graders just took a big test on percents. They had 8 formulas, and unfortunately, one kid shows up without the resource card. And the kid at the end of the class goes, "Yeah, I know I failed the test." It was a pretty smart kid. Kid knew what he was doing during the chapter. He wasn't failing anything, and I told everyone. Even yesterday, I made them all produce their resource cards, and they all produced them except for one kid. And then that kid remembered it today for the test, and then another kid forgot it. You will be the same thing. I'll stomp the ground, I'll yell, I'll scream, I'll say, "Don't forget your resource card." Somebody will. And then you'll get to this shape right here or this shape right here, and it will all become cluttered and jumbled in your head. If you show up on test day without a resource card, I don't think it's possible to pass the test. There's just too many formulas to remember. Okay? If you show up on test day without your calculator, you don't have enough time to finish the test. I'm writing the test with regular numbers, not friendly numbers, but regular numbers. I designed the test knowing that you have a calculator in your hand, knowing that all you got to do is do r squared times h times pi divided by 3. This is a 10-second problem. Once you identify the r and the h, it's 10 seconds to type it into your calculator. Don't show up without the resource card or your calculator. No, I will not give you either. Yes. Yes. What? We'll talk all about that when we get closer to test day. All right. What's the only way I can mess with you on this formula? If I put the diameter, and I will do that. Okay? So be ready for that. All right, let's do one real quick, or watch me do one real quick. Hey, this one, they can tell you the distance between the vertex and the opposite where this comes straight down. This is kind of more advanced stuff. That's called the slant height. They could have that distance listed. For instance, maybe they say it's 8 centimeters on this side. Okay? That is the only bit of extra information they could have on the diagram. Everything else, it's either going to be the radius, diameter, and they have to give you the height. They can give you the slant height right here. Be ready for that. The formula we're going to use is that one right there with the word calculator friendly, pi r squared h divided by 3. And since many of you, or at least a few of you, on your the worksheet we just did last night, you messed up because you didn't put a radius, you put a diameter. Make sure you look at it carefully and identify the radius. Secondly, you have to square it. It doesn't mean times 2, it means written twice, multiplied. In rare occasion, this is the only one, it literally does mean times 2. But that's a coincidence, that's not a rule. So we plug in our radius and our height, following PEMDAS. If we're doing it by hand, we have to do exponents first. 2 squared is 2 times 2, which is 4. 4 times 4 is 16. 16 divided by 3 times pi in any order that you would like to do that in. We eventually get to where it's going to be a repeating decimal here. We have to do some rounding. All right. Tonight for homework, I believe the worksheet says round to the nearest 10th. Remember, we're still doing volumes, so all units will be in to the third power, in other words, cubed. And remember, big picture, this literally means how many cubes fit inside this shape, like actual 1 by 1 by 1 cubes. There are about 17 cubes that can fit inside this cone. I don't know what's going on over there, but it looks like a bunch of not paying attention. Abby, what's your question?
If you have a repeating decimal that's like 33333.
Yep.
Do you just round it to 3 or
You do. All right, box 3. Here we go. Hey, look, I got a radius, I got a height. No extraneous information, just what I need. I plug those numbers into the formula. If you're doing it with a calculator and you have the big extra fancy calculator like this or like this, you can literally type it in as it appears. As it appears, which is pi times r squared, but r in this case is 10 times height. You should know by now where the square button is on your calculators. Christian, you still got the dollar calculator? All right. Anyone got the dollar calculator? For those of you that like they forget and all of a sudden it's test day, you show up with a dollar calculator. Christian, how do you have to do this calculation? If you have a dollar calculator. I know you don't right now, but I'm saying if you did, how do you type that into a dollar calculator? You got to do everything by GEMDAS, PEMDAS, individual pieces parts. You would first have to do 10 times 10, and then times 8, and then times 3.14, and then divided by 3. That's a lot. For those of you with the $100 calculator or the $10 scientific calculator, I'm looking at what he wrote in. He literally just typed it in as it visually appears. Pi times the radius squared times the height divided by 3. And that way, when he plugs it into his calculator, the calculator does all the heavy lifting. We haven't talked about this too many times, so I'm going to pause and make a quick little speech about what you need to do for the test. Okay? I said you got to do 3 things for the test and the quiz. What's the first thing you must do? You have to write the formula. See what I did? The second thing you must do is, I got to plug in the numbers. This is, I know we're not compromises about this. We're going to literally write the formula. We're going to literally plug in the numbers. Then you grab your calculator, get to the answer. I need those 3 things: formula, numbers, answer with units. Why am I making you go through that pain? If you get it wrong, I can't give you any points for getting it wrong unless I see that you know what you're doing. If you have this formula written and it's this shape, guess what? You chose the wrong formula. You get no points for that, right? But if you have the right formula for the right shape, well, I know one thing, you know what a cone is. If you plug in the numbers correctly to the correct formula, I know 2 things now. I know that you know what a base is, what a radius is, and what a height is. In fact, you know everything there is to know about calculating the volume of formula, other than how to get your calculator to do the work for you. That is why I make you do those 3 things, so that I, in the event that you get to the wrong answer, can at least give you a point or 2 for identifying the correct shape and the correct formula and plugging in the correct numbers. Now, clearly, if you write the wrong formula, you're getting 0 points. Okay. Questions? You're gonna hear me say that over and over again. One or two of you are gonna forget that. And you're like, well, I can do that whole thing in my head, or maybe I can do it, on my calculator. Just look at the picture. Lanny, turn around, please. All right, Brecton, what's the difference here? I gave you diameter, so what's the radius? It is 9. So be careful when I give you the diameter. You don't plug the diameter in, you plug in the radius. Okay? Once again, this is an inconsequential calculation with a calculator.
How did you get? I got 3.
Type, because this is not what's on the sheet.
Sorry.
This is what's on the sheet. All right, everybody do box 4, please, if you haven't already done it. Do box 4. You have those 3 things. You got the formula, you plug in the numbers, you got an answer.
Except for this one, yeah.
Well, just remember, if you don't do that for the test, I'm taking away points. And if you get it wrong, I'm taking away all the points. If you haven't done those 3 things. Formula, plug in the numbers, answer, and with units.
If you
I will take off points if you don't put units.
every time's gonna get square. And
Are we doing area or volume? Cubed. Area is squared. And we will do area, by the way. That was the way we took the quiz on. We do surface area. Obviously, that's another area. Hey, can you boys stop? You two? Anybody need help? Olivia and Amber have such excited looks on their face. All right, Amber, what you got for that one?
376.
About 376? Is that?
Yeah.
That's what I got. I rounded to 377, but what she got is more accurate than what I got. Okay, cool. Well, she knows what she's doing.
I got 376.
What did you use for your radius? Who said I got 120?
I did 6 to the second power, which is 36, times 10, and then
That's
divided
360. That's 360.
Right. 360.
You forgot pi.
Oh.
Who said that? Was that Gabby? Oh, that was Angie. Good for you. All right. I forget you guys swapped. So all right, Nate, you got the last one?
Oh, yeah. I got 200.
Okay, I rounded to 262. Don't forget your units, and we're good to go.
I got 83.2.
Are we good? Cones? It's just a different shape, different formula, no big deal. Priscilla,
How did you get
what's the radius?
5?
What's the height? Tell me the formula. All right, that didn't take too much. So, I mean, I guess I'll go back to my 3 steps. You write the formula first, confirm it with your resource card. Like you're looking at your resource card, oh, it's a cone. And he's asking me to find the volume. So I go to my resource card, I copy the formula from my resource card to my paper, then I plug in the numbers. I mean, maybe there's a chance there you won't make a silly mistake, like the 2 previous people who just, because you were one of them. How in the world do you forget pi?
Even I remember that.
I'm just going to say this. Most of the time, it's because you don't follow those 3 steps. If you had plugged in the numbers and looked at them as you're doing the calculation, there's a better chance that you won't make a silly mistake. Yes, Genevieve.
When I got the answer that you had gotten,
Yeah.
I realized that, hey, that doesn't make that much sense.
It doesn't make that much sense.
So I redid it.
All right. So as always, in every one of these sections, we get to, instead of you giving you the base and the height, then they leave one of those off and they tell you what the volume is and you solve for the other variable. So in this case, they tell me the volume is 150 cubic meters. They tell me the radius, but they don't tell me the height. It's still done the same way. Step 1, write the formula. Step 2, plug in everything we're given. I'm given the volume, 150. 1/3 is still 1/3. Pi is still pi. I'm given the radius, so that would be 10 squared. I just don't have the height. we grab our calculator, we do the method we can. 10 squared is 100. 100 times pi is about 314. So I get 314 divided by 3, which is about 104.7. Who's lost the one I just did right there? 10 squared is 100. 100 times 3.14 is 314. Calculator. And what's 314 divided by 3? And you could put pi, you get a more accurate answer than I got. Speak.
Why didn't you use the viral?
I'm going to. Okay, so if you choose to divide, you're going to divide that, you're going to divide that. That's 2 extra steps. How about we just do the multiplication first and then do the division?
Wait, so you would do 10
Squared
and then
times pi divided by 3. Now this whole right side is simplified. If I don't do that, then I got to get rid of the third, get rid of the pi, get rid of 10 squared. Now, how do you solve for h? Pi. And that's what you're going to do. So divide both sides by 104.7. I get a height of 1.4. Now remember, as soon as you get pi involved, it leaves from equation to approximately. It's no longer the exact answer, it's the approximate answer because pi you're rounding. Who's lost on that? All right. One more time. Hey, I'm giving the volume, I'm giving the radius, I'm not giving the height. Kai, talk me through it. Go. Next step. That's not 4 squared.
14.
Do it. Times pi.
Oh, I did 12.
And then,
6.
and then,
No, 1 by 3.
divide by 3 and we get,
Hmm.
give me to the nearest 10. What?
Well, okay, so I accidentally pressed.
Just do it again.
Don't clear.
You don't need to clear it ever.
Well, yeah, I know, but it was
Ever.
stuck up there so you can get the number.
Yeah, but you have a graphing calculator, you'd never have to clear it, ever.
I don't clear.
It's just the next calculation down.
205.
Okay, and 205.1 is what I got. And then, final answer, the height is about,
1.4.
I got 1.5.
1.5.
Did you get 1.4 or something bigger than 5?
No, I said 1.4.
Show me.
Oh, no, I got 1.4.
Yeah, and that rounded would be 1.5.
Oh, yeah.
I'm telling you, I don't ever clear my calculator. You know why? Because I can scroll up and look at what I just did.
That's what I was doing, and then I accidentally, it wouldn't let me get out of that.
You hit quit.
Quit? Quit?
Second quit.
Oh.
All right.
Oh.
All right.
And then it's still there.
Right, but it's fine. It's just on the screen. It's not going to use it for tabulation unless you hit enter for answer.
Oh.
The only time you ever have to clear it is when you take a big state test.
Really?
And not this year because, well, yeah, actually, yeah, we would clear that. If you bring this one in, I'm going to give you a calculator for the state test. When you get into high school, then you will use your own graphing calculator. And then I will, for those of you that have one already or putting cool games on it, I will be clearing your calculators in high school for the state test the one time, but I'll give you plenty of warning.
You're on state test.
I don't have all the details about it. All right, number 5 or box 5. Hey, what's the only difference here between this and the previous stuff? There are no pictures, it's just words.
I'm gonna use the picture.
I'm gonna do both. I got a cone. So 1/3 pi r squared h divided by 3. I got a volume, 2,500, and a diameter. Do we need the diameter?
Yeah, yeah.
No, I need the, so what's the radius? 20. So this is exactly what pi did before. You grab your calculators. 20 squared times pi divided by 3. That simplifies the right side. There's other ways of doing it. I find this the most efficient. You could get rid of the pi first. You could get the 20 squared next. Next year, I'll teach you how to get rid of fractions, but not this year. So what do we get on the simplified right side? How much? I can't hear what you're saying.
127.
there's no way because 20 squared is really big.
Yeah, I did that wrong.
20 squared is 400 times pi, which is 3, that's 1200. Divided by another 3, that's, well, we're getting back to 400 again, ish.
Yeah, 418.
415?
418.
418. Okay, that's what I got too. Jenna, you get that? Okay. Jenna, how do we solve? Okay, do it.
Outside the computer.
And we get,
5.97.
that's what I got too.
8. CM.
No, no,
No.
only for volume.
Sorry.
Do the math again. Or look what you typed in. I can scroll right up and you didn't put what that number is. That's the only reason why it's slightly off. Because you did 418 instead of 418.7.
Right.
How about you? You got a calculator.
Yeah.
Type in the numbers. It's no big deal now if you got a calculator. It's like, oh, I don't want to type in all the numbers. I'm going to type in some of the numbers. Type them all in. It's your calculator's doing the heavy lifting for the calculation. You're doing the heavy lifting on identifying the shape, figuring out what the right formula is, and then doing the algebra.
I have to type it in.
Oh, you also got to breathe too, right? Unless you have one of those breathing machines. All right. Are we okay?
Yeah.
All right. There are 8 minutes left to class. Grayson, hand me the homework. I might have grabbed it. Nope, I grabbed it, Grayson. Sorry. All right. You see us coming around with the homework? Once again, as I said the last couple of days, on this worksheet again, I'm still giving you some review problems so that it all stays fresh in your mind. So you're still going to see a cylinder. You're going to still see a prism. You're still going to see a pyramid. And then today's shape, the cone. And do not forget, don't turn your cone upside down. Ever. All right, Donovan, questions?
Nope, I'm getting this down pretty good.
He's probably not there. Darn it.
Well, it shows that he's live.
Oh, well then he's.
Hello?
His brother or sister. He has to watch them since his parents aren't.
All right, so
Hi.
no questions, and we're going to stop the video right here. If you have any questions, send me a chat or an email.
Bye, guys.